Hello and welcome in. My name is Mark, aka the Markster. This is video number 20 in the FreeCAD series. Today we're going to be revisiting this die model, and we're going to produce it in a different way from the way we did in the earlier, I can't remember exactly which video that was, maybe number 5, I'm not sure. We made it using the constructed solid geometry method, where we had a cube and a cylinder, a cube and a sphere, and we made a draft array, orthogonal, three-dimensional array, and we selected the spheres that we wanted for each side. It actually was a pretty neat way to make that model. You can go back and watch that one if you haven't already. First, let's get to which version that we're using. This is version 0.19, revision number 19694, and my operating system is Windows 10. Let's go ahead and close this model, create a new one. It was number 5. It was the number 5 video. I just saw that. So let's go ahead and create our spreadsheet. We have a macro set up to create the spreadsheet for us. All this does is switches to spreadsheet workbench, creates the spreadsheet, renames it SS. Actually, it doesn't even switch to the spreadsheet workbench, it just creates it from the part workbench. So now let's define our variables, and we're going to call one side length, and we'll call one pip radius. This will be the radius of the spheres that we'll use to create the little pips. Select both of these text labels, use our easy alias macro, and that creates the aliases. If you haven't been watching the previous videos, this is another macro that you can download via the Tools add-on manager. It's called Easy Alias. I also have a video showing you how to put it on the toolbar. Alright, and let's just use say 100 for the side length, and for the pip radius I'm going to use a ratio of the side length. That's going to be side length divided by, let's try 18. See how that's going to look. Go ahead and save our document. We'll call this one 20 die 2. Alright. Now we're going to use a hybrid style of modeling where we'll begin with the cube and we'll attach sketches to the face. And we'll use point arrays, drive point arrays to create copies of a sphere to put it at each point. Let's go ahead and create that sphere too. Alright, so now we'll set our side length and press the equals key, ss.ss side length, enter. I'm just going to copy this because I'm going to use the same value for all 3 of these. Paste. Right click here, right click, paste. Okay. And we'll set the sphere radius as well. And this is pip radius. Could have been set here as well without making a spreadsheet variable for it. Alright, now let's go to the sketcher. And this will give us an opportunity to practice constraining sketches. So we'll select this face, and we'll create the sketch, choose attachment mode, flat face. Now some of you are probably saying right now, didn't he watch his own video recently about the topological naming issue? Why is he attaching a sketch to a face? And the answer to that is, with a geometric primitive cube, that object is never going to change. There's no fear of this suddenly growing more faces or losing faces. Yes, you can do operations on it. For example, do a Boolean cut with some other object or fusion or whatever and end up with an object with fewer or more faces. But it's not going to be that cube object. It'll be a cut object or a fusion object or whatever. This cube is never going to change topologically. It might change the dimensions, but it'll always be a six-sided figure. So there's no fear when it comes to mapping to the face of a cube or any other primitive as far as the topological naming issue is concerned. The only primitive that you would be concerned about is a prism. If you were to change the polygon that the prism is based on, for example, going from a 5-sided prism to a 4-sided, you would lose one of those faces. So cubes is perfectly okay to map your sketch to the face of that cube object. Had we used the sketch to create a rectangle, or a square in this case, and extruded that sketch and then started mapping to the faces of that extrude object, there would be a risk of the topological naming issue. Although in this particular model, we're never going to change it to any other shape, are we? It's always going to be a cube because this is a die that we're making. Okay, so now we're going to use points to set up our points. Let's just call this one face number 1. So we'll put a point here, and we'll use the point array tool from the draft workbench to create an array of these spheres at this position. And we'll do that for each face. So if you haven't used that point array tool from the draft workbench before, this will be an example of how to use that as well. So we have 2 degrees of freedom, and that's the x and y coordinates of this point. And we just use our lock constraint to set both of those at once. Now we're fully constrained, but we need to set the proper distance. So for this one, we'll double click here on this constraint, press the equals key, ss.s, select the side length, and that's going to be the side length divided by 2. We don't just put 50 in here, because if we later change the dimension in that spreadsheet, then it's going to be different and it won't be parametric. So this is our way of making a parametric model. Now we're fully constrained, and this side, that's face 1. Let's name the sketch F2 here, and we'll call it side 1. How about that? Now let's go over to draft, and we'll select our sphere first. Select it first because it's the base of the array. Then holding down the Control key, select the sketch. And then we'll select our point array tool here. And now we have a point array consisting of just one sphere for this side. And we can cut that out of the cube, but we'll do that later. We can also relabel this point array. Let's call it F2. Try this again, F2. We'll call it PA1, point array number 1. And you see it consists of the sphere as the base and a sketch, side 1, as the point list. On a die, let's where is our view full screen? We're having a little problem with the video rendering there, and this will correct that issue. The opposite side of side 1 is where the 6-sided face is going to be on a die. So let's go to Sketcher again. With this face selected, create a new sketch. Choose the default flat face mapping mode. And this is going to have 6 pips on it. So we'll put our 6 points just roughly in the right spot. They don't have to be exact. Right click to get out of that mode. Now we could constrain each point individually where it needs to go with the lock constraint, but it'll be easier to do some of these other constraints first. So all of these are horizontal with one another. I'm using the block selection to select all 3. These are horizontal with one another. These are going to be vertical with one another. These vertical. These 2 vertical. And we have 5 degrees of freedom remaining. Let's go ahead and do this first one. We use our lock constraint. Now this is going to be, press the equals key, minus ss.ss side length divided by 4. And this one will be a positive value. Press the equals key here. Side length divided by 4. Now we have 3 degrees of freedom remaining. These cannot be moved up and down anymore. These can be. Let's go ahead and do this one next. We use our lock constraint. This one is going to be 75. It did not apply horizontal, only the vertical, because we're already constrained with this vertical constraint to have it lined up with this one, which is already constrained. So we only need to add this vertical element of that, and that's going to be 3/4. We say equals side length times 3/4. And we have 2 degrees of freedom remaining. One way to tell is kind of drag things around, see if you can drag them. The ones you can drag are the ones that still need to be constrained. So let's do this one here with a horizontal constraint. Equals key ss.ss side length times 3/4, and that's going to have to be a negative value. So we put a minus in front. We have 1 degree of freedom remaining, and that's this middle row. So let's do this. We can select it. There we are. Horizontal constraint here. This is a minus value. Side length divided by 2. Now we're fully constrained. And we'll rename this one F2 key, side 6. Go back to draft. Select our sphere since it's the base. Select the base first, then the points list. Apply the tool here. Create a copy. Create copies of a selected object on the position of points. It's creating a point array. And we can rename this point array PA_6. Now we have side 1 and side 6 complete. Now let's do side 5. Select this face, create a new sketch, flat face, and we need 5 dots, 5 points. Position them roughly. We have 10 degrees of freedom. So these two are going to be horizontally constrained to one another. These two horizontally constrained. These two vertically. These two vertically. The center will use a symmetry constraint. This is a point-to-point-to-point symmetry, in which case you select the middle point last. The order of selection is critical. We have 4 degrees of freedom. Let us position this first point with the lock constraint. Double click this, press the equals key, side length divided by 4, and this one will be the same thing. Now we have 2 degrees of freedom. See if we can select this object. It's not letting it move, you notice that? Why can I not move it? Because it's symmetrically constrained to this point. And this point is not moving. This point moves up and down. Now it's moving. Alright, let's constrain this vertical position on this point. It's going to be 75 in this case, but we're not just going to say 75 because it would not be parametric if we change the side length. Now we have one more to do. We can set the horizontal constraint on this or that one, either one. Let's choose this one. And that'll be side length times 3/4. Now we're fully constrained. You can close it. Let's call this sketch side 5. Let's go back to draft. Select our sphere, then our sketch. Create the point array. Go back to Sketcher. The opposite of 5 is going to be the 2 side. You add them up. You add up opposite sides, it's going to add up to 7. So this will be the 2. Side 2. Create a sketch, map to the flat face. We'll add our points. Add one here and one here. Right click to get out of that mode. Let's lock this one in place. This is a negative value. It should be minus 75. So that's 3/4. And put a minus in the front. And now this will be 25. Side length divided by, oops, clicked the wrong one. Side length divided by 4. Alright. Now we'll constrain this point. Can use the lock constraint on it too. And that's 3/4. And this will be minus 1/4. Put the minus in. Length divided by 4. There's a lot of repetition here. Now we're fully constrained with side 2. Let's go to draft. The reason I'm doing all these one at a time like this, let me rename the sketch. This is side 2. The way I can see which side is which, I don't want to accidentally try to map to a face that's already been mapped to. So that's the reason for doing these instead of doing them all in one go at the end, which would be more efficient, but could be error prone. Let's rename this point array PA5. And this one PA2. Right, yeah, this is 2. And this is 5. So now we have 3 and 4 remaining. And I'm just going to put 3 right here. Maybe it's right, maybe it's not, I don't know. But I know 3 and 4 are opposite. So we'll create a sketch here. And this will be the one with 3 dots. Let's use the symmetry constraint here as well. We have 4 degrees of freedom. Let's do this one first with the lock constraint. And this will be 1/4. Press the equals. Side length divided by 4. We're almost there. And this will be 1/4 as well. Side length divided by 4. Now we can position either one of these would work. This will be both the same. Side length divided by 2 this time. Let's copy this, Control C, and we can just paste it in the other one. Control V. That's a little bit less typing. Now we're fully constrained with side 3. Let's rename the sketch F2, side underscore 3. Back to draft. You can't see the points. The points don't show up in the 3D view when the sketch is closed because they're always construction mode. Every point is always construction mode. And let's create this one. So that's side 3. F2, let's rename this one. Not really necessary. And now the last side, side 4. Select the side. Back to the sketcher. Create flat face. And we need 4 for this one. Put them in the approximate location. And right click to get out of this mode. Let's do the horizontal here. Horizontal constraint for both of these. Vertical constraint for these. Notice we're not using any construction mode lines, line segments or circles or anything. It's all being done with points and using constraints tied to the variables in the spreadsheet. Let's do this lock constraint, and that's going to be minus 25 for this one, plus 25 for this one. Press our equals key, minus side length divided by 4. Okay, and this will be a positive one, 1/4 equals side length divided by 4. And we have 2 degrees of freedom. We can set them both on this dot here, on this point. Use our lock constraint. This is minus 3/4 and plus 3/4. So let's do the minus 3/4. Equals key, minus ss.ss, select side length divided by, it's at 3/4, wasn't it? Times 3/4. And this is going to be positive 3/4. Side length times 3/4. Alright, and that's it for the sketches. We'll rename this one side 4. Select our sphere. Control key down. Side 4. I use control because I'm in Blender mode. If you're in a different mode, I'm not really sure how to do multi-select. It's probably the same thing, but it might not be. We create our point array. Okay. Do you like the size? PA4. You like the size of these spheres relative to the size of the die, the cube. They look okay, but let's see if we go a little bigger what it looks like. Divide by 16 instead. Press enter. Let's see what that looks like. That's a little better. Maybe a little bigger than that. Let's try 14. Press enter here. Yeah, I like that. You can play around with that and get the ratio that you prefer. So what we're going to do now is fuse all of these point arrays together, and that way we'll have one fusion object to work with when we cut it out of the cube. And let's set the color of the cube. What color do you like? Let's try green today. And the fusion, what color should we make these? Red, maybe? Select the cube, then the fusion, do the cut. So that's our green and red die using the sort of a hybrid modeling method, where we begin with the primitive and use sketches. So we learned a few things today that you might not have known already. You might have not have known that you can map to a cube and it's perfectly safe. There's no way to turn this cube into any object other than the six-sided object that it is. As far as I know, it's perfectly safe. Now, if you map to the cut object, if you map to one of these faces, then you might run into some trouble down the road if you go back and modify some of these sketches. Not that you would. So it's kind of comes with experience when you can get away with doing certain things that maybe are not best practices. You certainly can get away with mapping to cubes, cylinders, cones, wedges. That would be fine. I would not map to a prism. If there's any chance, I might decide later to use a different polygon as the basis for the prism object. That's going to be it for today. I thank you for watching, and as always, have a great day.